Everyone. In this video, I'll be briefing about object generator and how to use a beam connector in ANSYS. So this is only for a demonstration purpose. So for that, let us go into a static structural simulation. We are going for the default engineering data material. Then geometry, I'm importing one geometry, it's plates.step file, or you can browse the file. Now we have imported the geometry. Now let us go into the model. Let's wait for some time till the model window get opens. Okay. So in this window, we can see there are two plates. So actually we are assuming that these two plates, we can see multiple holes that are concentric holes. So these two plates has to be connected by using these many number of bolt. Okay. So one way is we can in the modeling part, it's in the modeling time itself, you can make and another body here on each of these holes that can represent as a bolt. Then based on your requirement, that bolt you can model as a rigid or flexible member according to the requirement. So here for this demonstration, we will be assuming the bolt as a beam element. So then we need to insert that beam element in all of these holes. So I'll just demonstrate how to do that. So for that, first we have to go to the connections. So here I'm not explaining about the geometry, material, coordinate system, and other parameters. So in connections, right click insert, we need to insert a beam. Okay. So once you click that option, here they're asking few more things about it. So first thing is the radius. So we just need to know what is the radius of this hole. So maybe for that we can just change this unit system into mm. Um, yeah, now it is in mm. So I think this whole diameter was 10 mm. So let's click it here. So let me see. Yeah. So at the base, it is written that the radius is 5 mm. So this is a 10 mm diameter hole. Now here radius. So we are typing it as 5 mm. Okay. Now we have two sections that we have to fill. One is this reference geometry, and second one is the mobile geometry. So here nothing, we are just taking one of the plate as a reference and one of the plate as a mobile one. So and here in each of these thing we have to fill the scope. So they are asking for scope as well as body. So once you fill the scope, the body will be automatically getting selected. Or the same thing you can do by providing the required coordinate numbers also. X, Y, Z values you can type. But selecting the geometry is easy, so we will be going for that. Anyway. So I'm selecting the base one as my reference one. So for that, I'm going to this option. Now we need to select one circle. So this sphere, so this cylinder I'm selecting. I'm doing apply. Now this we can see in the reference section it is almost filled. By default it has filled. Now we are going to the mobile. There also we are clicking the scope. We are selecting the corresponding hole. Now by default this is in surface selection, so I think it will be fine. Apply. So some error has happened because we did not select the full base circle. So let's correct that. So for that again go into the reference. We have to go for the scope. We are reselecting that. Zoom it. So we are selecting one circle and control and second one apply. So two faces have selected. Then the same thing we have to do in our mobile component also. So once already selected, control and second the surface also selected. So here face we are applying. Yeah. Now by default this bolt. Now by default a beam element has came which is having a radius of 5 mm that came between these two components. Right. So now a connection. Now we are just assuming this is a bolt. Now, based on your further things about your simulation, you can give the other parameters and all. But now it is taking as a beam element. Okay. So this is how we are inputting a beam as a connector. Okay. So that portion is completed now. Now we need to repeat the same step for all these number of holes. So either we can do it manually, but it will be little time taking task. So we will be trying to do it. We'll try to automate the process. Now we know we are having. So the basic step involved in this making the beam was we need to select a reference surface. We need to select a mobile surface. Also, we had to select a radius of the beam. Correct. Now we know all the holes in this base we will be our reference geometry, and all the holes in the top plate that will be our mobile geometry. So now for the easy of selection. Now we know that if I want to select each of these thing, we have to like click, press control, then select each and everything. So just to so in this thing, okay, number of holes are less, we can select like that. But just still for the sake of easiness, what we can do is we can just select all these holes, then we can just categorize that under a name. So instead of selecting this hole each time, you just have to select that name. So that whole of the whole this like all of the holes will be getting selected. So in ANSYS, the option for that is name selection. So let me demonstrate that. So here in this design tree, there is no name selection enabled right now. So what I'm doing is I'm selecting one of this this cylindrical surface, right clicking. Then we are taking it as create named selection. Once we do that, now we can just give any name for that. I'm giving it as a top plate. So here we need to, okay, now next task is we have selected one. Now we need to select the whole holes which are having the same property. So for that we are going for size. You can even do by type, location, etc. But for now I'm going for size. So let's see what it does. Once you press OK, nothing happened, correct? But in the left side design tree, you can see a named selection tab has came. If you expand that and click that, now you can see all the holes have selected, but we actually wanted to select only the top plate and we name it as a top plate. Select the total cylindrical holes in the bottom plate and name it as bottom plate like that. But now this everything has selected. But now what we will do, we will try to uh, filter it out. Then we will name it accordingly. Now we know by this named selection. So named selection is nothing but we are just giving some condition like greater, equal, cylinder, sphere, like that. We are giving some condition. We are giving some word condition for so that the software will take that conditions or the constraints. Then that will be selecting the geometry in accordance with that. So now you can see when we went to the name selection by default, these many things have came. Add face size equal square 156, etc. So this thing came because of our selection. Now we know that the top plate named name selection is having this many data. Now what we want to do, we want to remove either we want to select only the top plate or we want to remove the bottom holes from that. So we are doing the steps for that. So before that, let's see where is the coordinate system of this whole assembly is staying. So for that, click on that. Okay, now we know the coordinate system is staying at the bottom face of the bottom plate. Now let's again go to the name selection. So now we know thickness of this plate is actually 10 mm. So we can actually use different condition for us to have this name selection. Now what I'm trying to do is I'm just here adding one more criteria. Right? Now what we want to do, we have these many holes. We just want to remove some holes from that. And finally our selection should be finally our selection should be only the top plate. So the first line in this command is selecting all the holes. So the second command, we are just subtracting some holes from that or specifying something. So either we can use a filter. If you use a filter and put some condition, that will be based on the filter condition, it will be choosing some holes from the top plate. So, or we can remove some from the top like that. So let's use the filter for now. So here entity type by default came no criteria. Now we know that coordinate system was located at the base of the bottom plate, and distance between these two are almost 50 mm. Distance between these two plates are 50 mm. So what I'm trying to do is that the height is along, you can see the coordinate system, it is along y axis. Now we can just give a command that we just need to filter out all the holes which is coming at a y coordinate of greater than or equal to 25 mm, which means we know at the base it is 0. When we go to the top surface of the bottom plate, the y coordinate will be 10. Then once we reach it to this bottom surface of top plate, it will be uh, how much it will be 50 mm or it will be 60 mm, like that. So this is nothing but we are just giving some mathematical condition or some location data or something for us to filter out something. So I am giving as my criterion as location y. So what we want, we are naming the top plate. So we need everything to be filtered out that is having in this range. So we are giving greater than or equal to, greater than or equal. So we need to select the holes which are greater than maybe 25 mm. So which is greater than 25, which is located at a place that is 25 mm or more from the coordinate system. So let us generate it and see which one it is selected. Yeah. Now when we generated it, you can see the selection has changed and only the top plate got selected. So we can call it as top plate. Fine. Now we are making another copy of this by using duplicate option. We are renaming it as bottom plate. Bottom plate. Now since it is a duplicated one, it is also having the same criteria. But here we know we just want to select the holes corresponds to the bottom plate. So we can use the same criteria. Only thing I think we can just make it as maybe yeah less than 25. So I think everything coming under 25 will be always the bottom plate. So generate to see all the holes in the bottom plate has selected. Now from now onwards, if you just want to select every hole in the top plate, you only need to select a named selection, named top plate. Same for bottom plate also. Now this portion of named selection is completed. Now we are moving on to the another uh, step where we want to copy this bolt into all these holes. So let's go to the first bolt that we have made. So in the right panel, you can see we're having a reference body that is the bottom plate. We are having a mobile body that is the top plate. So we just want to repeat the same thing. Instead of bottom plate, what we can replace? We can replace our named selection of bottom plate. Instead of the hole in single hole in the top plate, we can replace it by a selection of a named selection top plate. Correct. Now for making this process, we have to go to home, manage, and object generator. Now a window has came. Now here what we want to do, select the named selection to use as the reference side. So we know what we want. We want bottom plate as our reference. Here we need to just give in the same order of how we have given for our previous bolt connection. Now mobile, we know this is a top plate. Now they are asking object will be created for any pair of centroid on opposite sides of the connection whose distance falls. Now we just need to specify a range of the distance so that software will automatically assign an condition for that. Now actually we are actually in a step of object generator. But for us to get this window, we have selected actually, we were having a pre-selection of this particular connection. So once you select this connection, then go for object generator, then software will be actually trying to copy or repeat the same connection that we have copied. If you were not, let's try once that. Let's not select this circular or Plato option here. Instead, I'm just press escape or just clicking on material or maybe geometry. We are just clicking on the geometry. Go to manage and object generator. Now that particular option is not coming. So if you want, I can just click on this option. Yeah, everything has came. So now we will just select the reference as the bottom plate. mobile as the top plate. Then we need to just give a minimum and maximum length distance between the centroids. So we know from the left side tree we can see the length of the bolt is beam is 60 mm. So here we have maximum we are giving maybe like a little bit more than 60, that is 61. Let's let it be for now. Now we have already one beam generated, so we do not need the original one. So ignore the original. Yes, we're ignoring that. If you uncheck it, I think it won't ignore. So we are ignoring it. Now just press generate. Yeah. Now you can see for all the selected holes that beam connections has copied. Now it is there in the design tree also. That's it. Thank you.